So now that we have our significance manager set up and everything is good to go with the quote unquote CPU LOD, I want to go ahead and work with the animation budget allocator. Now, I was initially intending early on to implement this kind of regardless, but I wasn't looking into tying it to the significance manager. And then after watching a talk by Epic, we already did kind of the groundwork for it. And if you're not familiar, the animation budget allocator can do its own significance work. But because we're already doing it, we may as well just simply, well, apply what we have. So to begin, we're going to go ahead and enable the plugin. So search for animation budget allocator. So enable and close down the editor. And we'll just recompile and relaunch. So what the animation budget allocator is it's a replacement or a subclass of your skeletal mesh, and it's a system that you can specify a budget. So like, for example, how many milliseconds do you want these meshes to take up in total? So let's say we wanted to take up 1 millisecond in total. So what it's going to do is it'll go through and based on significance, it will throttle the ones that are farther away more. So they're going to have a lower tick rate and look a little bit worse than, say, the ones up close, which are going to be throttled less. And then if you are within budget, the ones up close won't be throttled at all. Okay, so we got that enabled. And there isn't a variable we would need to add to our console. So a.budget.enabled, because you can see the animation budget allocator by default is not enabled. So we want to bring that into our config default engine. And let's go down to our significance manager at the very bottom. And we'll make a new section just called anim budget allocator. And we're going to set a.budget.enabled to 1. So now that we have that, we just need to go ahead and load the animation budget allocator. So if we look at the animation budget library, this is unfortunately not exposed to C++ because the header file, for whatever reason, is in the private folder. If they made it public, that would be really nice. But we're basically going to be doing this specific logic here. So we just need to load the module. And basically, if this is already loaded, it's just going to get it. And then we want to enable the module. Well, not enable the module, but enable the animation budget allocator. So to begin, we are going to want to, because we need access to the world, we are going to want to set up a simple world subsystem that I'm going to make kind of dedicated to this, so to speak, because that subsystem on begin play, we can know that the world has been loaded. We can recreate these functions very easily and actually have access to them. So let's go to our core module.build.cs. And first thing, let's just add a dependency to the animation budget allocator. Then let's come over to our public folder. Let's add under performance, actually, Unreal class. We want a world subsystem. So uWorld subsystem, and let's call this one the animation budget allocator subsystem. Now, this is honestly really not necessary. This could be done pretty much anywhere. However, I don't like the idea of trying to load this module and stuff in a place where it doesn't make sense to have it there, if that makes sense. But regardless, override public, and we should have a on-world begin play. And let's create the definition. I don't think there's anything in super, is it? Yeah, it's just empty. And in here, we just want to do this logic to load and basically enable it. So let's copy and paste. So include the I animation budget allocator, and we also need to include this file here. So if we go to it, that is in the animation budget allocator private animation budget allocator module. So include animation budget allocator, private animation budget allocator module. Then replace world with get world and set enabled to true. So I'm also going to just move this within the if statement. So this will just go ahead and fetch/load the module and enable the animation budget allocator. Now I want to do this by default just so that it's up and enabled and I don't really have to think much else regarding it. So let's see. We could add, I'm being blind, right here. We could basically recreate these functions. And I'm kind of for that. So I'm just going to copy and paste. And I don't want these to be exposed to Blueprint because Blueprint already has their own version. Let's create definition and create a definition. And same thing, we can just literally copy and paste. And I'm going to remove the world there. So instead, we just have get world, and we don't need the context object, or sorry, get. But yeah, actually we do need the world because we are a static function. So we'll just leave it as is, and then same thing with the settings. So copy and paste. So we now have access to it from C++. So what we can do now is on begin play, instead of having duplicate logic, we can just call enable animation budget, pass in get world from, just get world and true to enable it. So we can at least, enable and disable at will. Okay, so we have our animation budget allocator. We have everything being loaded and all of that. Now we want to make use of it. So let's head to our zombiepond.cpp. Actually, the header, and we're here in the constructor. We need to use the object initializer. So const f object initializer, object initializer. Let's copy that. And what was the syntax? Was it just super object initializer dot set default object class? And I do believe this to be isn't this a template function? So we want the U skeletal mesh component budgeted. So we need to include that. And also at the same time in our zombie pawn, zombies module.build.cs, let's add a dependency to the animation budget allocator, because I believe that's the module that contains this, correct? It'll show me the path. Or don't show me the path. Thank you. There we go. Oh, come on. Right, so that isn't, dang nabbit. So plugins, runtime. Okay, so yeah, it is in there. So we need to have a dependency on that module. And then for the name, that is I think it's a character mesh component, prevent creation of the component with. Yeah, so it should be the mesh component name. So memory serves, that will basically replace our current skeletal mesh component with the animation budgeted one. So now in our constructor, we want to go ahead and just set the defaults. So use skeletal mesh component budgeted. Skeletal mesh component budgeted equals cast to use skeletal mesh component budgeted from get mesh. So we're just converting our character mesh component over. And from here we have, so we can, set component significance, and we can go through, and there should be, let me see. I know the values in the editor. Actually, I'm just going to go ahead and shut it down, and I can visually see them there. So I'll comment that out, recompile, and relaunch, and that'll also let us know that, whether or not everything is okay. Okay, so we have some issues in our world subsystem here. So we need to go ahead and add a forward declaration for F animation budget allocator parameters. So let's add that up here, and hopefully now we should be good to go. Okay, Now that we are back in the editor, we can go back to our zombie pawn, select the mesh, and we are now using the skeletal mesh component budgeted. Now in terms of options, we have, actually these are kind of correct by default, so we don't want to auto calculate significance because we're doing that already. We want to auto register. And yeah, that is pretty much it there. So now we want to go ahead and make use of it. So let's go to our zombie pawn, and we don't need that anymore. Go to our register with significance manager, and we ended up removing the post significance function. So we need to actually add that back. So I'm going to copy and paste and call it post significance. And then it needs to have the new parameters. So those were the object info, then a couple of floats. So I'm going to go to register object, go to the post significance function. So it's float, float, bool. And we are using that. I don't remember exactly what the parameters were off the top of my head, like the names themselves. So let me go ahead and look that up really quick. Okay, so it's just the old significance, the new significance, and whether or not it was final. So float old significance, float new significance, and bool be final, meaning that this is the last, I guess you could say, change, so to speak, of it. So we don't want to return anything. It's not going to be a float. And we're going to grab the post significance and pass that in as the next parameter. Now, given, let's see, we need to, then basically we have our new significance, and all we're doing is just basically passing this in to the animation budget allocators. So that way it can gauge how much to throttle which specific actor. Well, not necessarily an actor, but the skeletal mesh. And if you remember, the way we are ordering these are going to be in order from closest to farthest. So the one up here, right here, is going to be throttled less than the one back here, just due to distance. So all we have to do is just get our mesh. So we want to cast to the U skeletal mesh component budgeted from get mesh and call set component significance. And we just pass in the new significance. Not sure why I did that. Ooh. Significance. Stop adding things. Right, then the next parameters are things that we do not necessarily care about. So we don't want to tick when not rendered. We want to allow reducing work. And we don't want necessarily to interpolate yet, but that is an option we can do. So, given the nature of the work that we were doing, we can also convert this from sequential to concurrent, which will speed things up a little bit more. And that is pretty much it. So I'm going to go ahead and restart the editor. And we can also actually cache this as well. So I don't need to cast every frame either. So that's probably not a bad idea. So I'm going to stop the build and just do that. So in the header here, let's go down where we have some U properties. So U property, let's do T object pointer to the U skeletal mesh component budgeted, and let's just call it mesh budgeted, or better yet, character mesh budgeted. And we'll forward declare. Actually, I don't like using the word character. Let's do pawn mesh budgeted instead. So that way, if we ever need to convert to a pawn class, it should be less just overall renaming. So now we can go to, maybe we can probably do this in our constructor right here. So pawn mesh budgeted equals get mesh, and we need to cast to U skeletal mesh component budgeted. All right, budgeted. There we go. And now we can use pawn mesh budgeted in place of our cast to call set component significance on. So now we can go ahead, compile, and relaunch. and give it a test. Okay, once we are back in the editor, we can close that down and just press play. Okay, so I also want to go ahead and remove those logs there that are being spammed. And we can actually reduce some of the work being done there too. So let's go ahead, take this logic and remove everything but distance. So you can use this somewhere if you want. That is up to you, because we are going to be doing some work to kind of figure out if someone is, say, behind us, we can make them just overall be less significant by default. So we take that into account with, well, in addition to distance. Okay, so let's go ahead, clear the log, and hit play. So we can actually visually see this as well. So if we do a.budget.debug.enabled1, let me actually make sure. Do we have it enabled to begin with? Oh, so it is still disabled. Okay, maybe I got to put that in a different spot. But for now, let's just enable it. So a.budget.enabled, set it to 1. Now when we press play, we can see the debug. So what we want to focus on is, you see where it says high on the right-hand side. So that is the level of detail, basically. So high fidelity. And then you see that 1 right beside it. There's a little bit of space between that and the number on the left, but that is how many frames it is basically delaying. So this is going to be running once per frame, which is good. That is nice and smooth. And so are all of these. The reason being, they are all in budget. So what we need to do is just bump these numbers up. So grab all those, and we'll just duplicate a handful of times. Okay. So press play, and it's kind of hard to see because unfortunately when we fly around, it gets rid of it. But you can see, the guys that are up close, these right here, they are delayed just no frames. They're running once every frame. Then the ones that are a little farther away, so these two right here, or sorry, they're kind of flickering on and off, but they're being delayed a couple of frames. And then the ones back there, that looks like a 6, and so on and so forth. And we can actually kind of see this working as well. So like the farther back we go, they don't always have necessarily like priority. So it's kind of whoever is rendered closest. So you can kind of see this guy over here has a 2 on the far left, whereas this guy over here has a 1. And if we go over to this side, this guy has a 1. It's just very hard to read. It kind of makes it a little bit difficult. But we can also see it in action by flying our camera to the end. And you can kind of see it was a little bit jittery at first. Yeah, so we're going to want to replace it with some running animations, and that'll more so show it better. But yeah. So the only thing we have to do now is go ahead and fix that one issue of not being enabled by default. So if we go to our config default engine, my guess is it is this. So let me check into that. All right, so it does seem to be that. So let's replace it with console variables. So I guess that has to be something valid, maybe. I'm not entirely sure. But we can go ahead and close down the editor. I'm going to save, then recompile and relaunch. Okay, once we are back in the editor, let's try a.budget.enabled. And there we go. So it's printing out 1, which means it is enabled by default. So when we press play, we can go ahead and enable debug and see that everything is working. So you can see our significance for the LODs, so 0, 0, 1, 2, 3, everything else being basically 3. And yeah, that is pretty much it. So what I want to do now is do a quick profile. So to mimic the setup we had before, which was 60 zombies, I'm going to set that back up really quick. Okay, so I went ahead and placed down 60 zombies just like we had. I want to go ahead and re-enable the state tree logic. And in the zombie pawn, I want to grab the mesh, and there is another little small optimization we can do, which I have actually already enabled. We are already using the animation budget allocator, so we do not need to enable update rate optimizations, but we do want to enable used fixed skeletal bounds if you haven't done so already. Now, I did that a while ago and accidentally saved and pushed it, so that was basically on by default, as well as our previous profiles. So we actually need to load the session browser up. So these two here already had these optimizations on. So it was using the update rate optimizations and used fixed skeletal bounds. So we're not going to really see a difference here. So it's not a perfect on and off comparison, but it should be a decent one. So I'm going to close out of the editor and do another profile just to compare. So let's launch the game. And we should see, yep, it's starting to capture with Unreal Insights. And same thing, I'm going to do about the 15-second mark of just backing up the hill and see what we get. Okay, so there we go. We definitely need to smooth out their rotation overall at some point. And there we go. So we have the previous one, and which is after we did the optimization, and our current. So I'm just going to load the current, enable, I just want to focus on the game thread realistically. And we'll just kind of see, and load up the old one as well, and just see if we have any noticeable improvement kind of out of the box. So same thing, I just want the game thread and dock it to the top. And let's go somewhere in the middle, say, I don't know, we'll go at about where that mark is, right before 780. So right before 780, which is right there. Okay, so let's look at the overall just average tick times here. So 9.7, 10.3, 10.8, 11.8. So that one's pretty high. 10.9, 9.2. So I'd say we are in here's a 9.3, kind of in the lower tens. So maybe averaging. Oh, here's a high one at 12.2 and 11, back down to 10. So I'd say we're about maybe 10 and a half on average milliseconds. And come back over to our previous one. Now here we have 11 and a half, 12.6, 11 and a half, 13, 13 and a half, and everything overall is just a little bit higher. So we're about, I'd say consistently 1 to maybe a little over, so 1 to 1.1 or so milliseconds higher at a cost. So yeah, I'd say we are overall saving about 1 millisecond just with the default settings, and that's, well, obviously a good thing because that is a additional millisecond that we have free for other stuff. And we didn't really have to do anything other than just set it up and enable it. So we can tweak it to make it more aggressive and really just overall just play around with it, see if we can maybe bring it down farther. But overall, I'd say that is pretty good. So I'm going to close out of these and rename this one because I'm trying to keep track. And this will be the Anim, what is it? The Anim, what was it? The Anim Mesh Budgeted. And I'll call it default. So that way we can kind of keep track as to how we are improving. Because the first one, right here, we were having, I think it was between like 13 and a half to 14 and a half. I think it was around like a 14 millisecond average, give or take. So we brought that down to around 10 and a half. So saved between 3 and 4 milliseconds each frame. And we didn't really have to do much kind of from the get-go. We did our rewrite that was kind of needed anyways. And now we just have the animation budget allocator set up and working. So what we can work on, I guess, later is just the actual optimization specific to the zombie. So controlling tick rates and all of that. So with that said, I will see you in the next video. If you like what I'm doing and you want to help support me, you can find a link to my Patreon in the description below, where you can also get early access to this entire series.